So today we're going to be looking at center of mass. I've got a few colleagues with me who are going to be assisting me during the experiment.
Good day to you all. I am Andile Moena, one of the physicist students.
Good day to you all. I'm Sandy Lemuri, the physicist at Shambhala High School.
Good day to you all. My name is Francis Omar. I'm one of the physics students.
All I kind of take out the only physics student.
Good day to you all. I'm Owen Swada. Only
Good day to you all. I'm privileged to know that the only physics student.
I'm also Adi Shandov. I'm also part of the physics class. So on today's tutorial, we're going to be looking at center of mass. Our objective is to determine the position of center of mass on an irregular plane lamina. What you first need to know is what is center of mass. Center of mass is the imaginary point at which the entire mass of a body acts on. So, what I mean about plane lamina is irregular plane lamina is an irregular plane lamina is just any shape, a flat shape, just like this one, which I have here. You cannot actually assign any shape to this, but you can determine the position of center of mass. So, right, let's go back to our objective of today. So, our objective is to determine the position of center of mass on an irregular plane lamina. We should write this one right here. So, what I need is a plane lamina, a divider. I don't actually have a pin, so I'm going to use this divider. A plumb line. A plumb line is any weight attached to a string. Then I'm going to need a ruler and a pencil. So, what I'm going to do right now is attach these together. So, I'm going to suspend this plumb line on this lamina. Okay, I kind of left out some important details. So, before you suspend this plumb line, you must first punch at least 3 holes on any point of this plumb line, of which I've already did that. So, I'm going to suspend this plumb line on this lamina. So, I'm just going to swing it. So when this lamina is stable, I can now take my white marker, then mark the points. Then I'm going to remove this line, then draw a straight line just along those marked points of the plumb line. So here we do it like this. We just have to join these marked points. Then I'm going to repeat the same procedure again for the second point. Just suspend this plumb line on this lamina. Lamina should be free to move, to swing like that. So I'm going to swing again this lamina, and when when it is now stationary, we can take the markers. So I'm gonna take my white marker and mark the point. Then I'm gonna join the points along this marked points of the plumb line. So I'm just gonna join these marked points over here. For the third point, I'm just going to repeat the same process again for this point. Can you do it for me? Just make sure it can move. It is up too soon. So I'm just gonna swing this lamina once again. Oops. So I'll mark this point. Then I'm gonna join these points along the pad line by just drawing a straight line along those marked points. So you're gonna realize that there's this point where these lines intersect. So this line of intersection, that is the center of mass. Correction, this is the point of intersection. So my point P, this is the center, the position of center of mass. So to prove this, just see if this experiment is going to work out just as prove it. If the experiment is worth the experiment. So I'm just going to put this right at the point, at the position of center of mass. We can actually see that this lamina is balanced and it's not falling. It is at equilibrium. Thank you. Wherever you want to, or in classroom, there's just a simple experiment to just determine the center of mass. So once again, thank you very much for watching our video. Hope to help. Thank you very much.